Mike, I think we should go ahead and get started.
Okay. You can go ahead.
The broadcast is now starting. All attendees are in listen-only mode.
Hello, ladies and gentlemen. My name is John Sennett, Director of Channel Marketing at NetGen Communications. Our two presenters today are Mike Coffey and Cliff Schornack, who founded Commetrex over 20 years ago to develop and market value-adding technology products such as fax modems and protocol software for the telecom OEM. So with this pedigree, it's safe to say if they don't know it, it's probably not fax. Mike will add a few details on our fax technology savvy in a few moments. I'd like to take a moment to explain the relationship between Commetrex and NetGen, the co-sponsors of today's webinar. About 8 years ago, Commetrex did extensive testing to learn why service providers were having so many problems with FoIP and carrier networks. Well, they were successful, and the result is a patent-pending technology we call Smart FoIP. Although Commetrex's business was to license technology to OEMs, they decided to found NetGen Communications to focus on enterprise products for ITSPs and the channel partners, and, of course, to commercialize Smart FoIP. NetGen's first product is Smart ATA, with Smart FoIP license from Commetrex. The two companies have common ownership, but are separate organizations. Today we want to review the different ways various companies in the industry, including ours, of course, have been able to deliver fax and fax-related products and services that are mostly problem-free. I would now like to hand it over to Mike.
Thank you, John. And welcome to our webinar, ladies and gentlemen. My name is Mike Coffey, as John said. And if any of you attended our first webinar, you might find some of this a little repetitive. But our focus today is going to be on surveying the industry to try to give you the information you need to make decisions about how you can make use of the Internet to deliver trouble-free facsimile services to your customers. Now, that's kind of a convoluted way you might be thinking to say FoIP, trouble-free facsimile services to your customers. Well, we reserve the term FoIP to mean a real-time fax over IP, conforming to industry standards, but that's not essential to it, to the definition. Real-time fax over IP is what we need by FoIP. Now, there are companies that do a fine job of delivering facsimile results to clients that don't really use FoIP. They use different architectures and schemes to get around the problems that they discovered back in, well, 10 years ago, say. And we want to give you the information that you need to understand the differences between these various approaches. Of course, the F in FoIP stands for fax, and we're going to actually, and I hope we don't bore you too much, but define facsimile or fax. We're going to talk about the architectures of faxback, faxbox, and a few others, and of course our Smart FoIP. So what do we think that we can do this? Well, we have some pretty good fax chops. We've been doing this for 22 years. We had we actually added fax into a voice board in 1993. Happened to be NMS or Natural Microsystem voice boards, if any of you go back that far. We invented terminating T38 and shipped it in May 2001. And we added the modems to terminating T38 so that a call could, or server, I should say, could send and receive faxes using either T38 or G711 fax using the fax modems. And in 2002, we opened the first and only T38 interoperability test lab. A few more words about this later on. But we completed interop testing with some 12 different companies, just about every company at that time in the industry that had a gateway. And we believe that the industry is profiting to this day from that early interop testing that we and our testing partners did back in 2002, 2003. We closed the lab in 2003 because it was no charge and it started to eat up a lot of our time, and we felt that we had accomplished our mission. We shipped the industry's first HMP media server. Maybe that's disputable, but it was in 2002 or 3. And we actually figured out how to send real-time faxes over the Skype network. It didn't turn into a viable commercial product because it had to have the same software and a little hardware widget on both ends, and that creates a serious chicken or egg problem for a product. And then our latest serious innovation along these lines was Smart FoIP, which we'll talk a little bit more about later. Okay, so what is a fax? Believe it or not, lawyers and judges have wrestled with this in several court cases, or what they call Markman hearings prior to a court case. The judge and the opposing lawyers in an intellectual property case make sure everyone agrees to the definition of the various technical terms that will be used. And I found a case that was from the Central Federal District in California. I think it's the 12th District, and they actually defined fax. Of course, when I saw that, I perked up. And in so many words, paraphrasing the judge said that a facsimile is an image file transferred between two endpoint terminals using the T30 protocol. And that is what we're talking about today, as well as other ways that image files are transferred from one place to another. Okay, T30. So what is T30? This is one of my pet peeves. A lot of people use the term T30 in ways that they shouldn't. It's an ITU recommendation that is a computer-to-computer protocol. It's the protocol that fax terminals use to exchange image files. It could actually do other things, but that's what we're talking about today. The title page is reproduced here. So that's what T30 is, but I can tell you what T30 is not. And this really kills me when people use T30 as a synonym for analog or TDM or G711. It's not. It's a computer-to-computer protocol. And we'll be talking about T38. It's another ITU recommendation that came out in 1098, October 98. And I should point out that we shipped our first one in, Cliff, are you there?
Yes, I'm here.
Well, it was in early '99 that we shipped T38. Do you remember?
Yeah, about that.
Okay.
99, right around 2000. 99.
So we go back a long ways. We think it was the first independent commercially licensable T38 in the industry. So the common definition or terms that I want to make sure that we all understand is that T30 is used by these two endpoint terminals to transfer an image file. This terminal can send to this terminal. This terminal can send to this terminal. And the T30 fax, the designers of it, the T30 protocol, the designers had in mind, although it's not part of the requirement, they had in mind that it would use the public switch TDM network. So the timing requirements of T30 are supported by the PSTN. But when you come along and say, okay, I want to use an IP network as my telephony transport, I want to use it to transport voice, maybe video, fax. So you need to take scissors and cut the PSTN cord in the middle and insert a packet network. Well, as soon as you do that, you screw up the timing of what's going on the two endpoints. And so T38 is a protocol that gateways on either side of the packet network can use to talk to each other. It's another protocol. And the purpose of T38 is to render the packet network transparent to the endpoint terminals. Make it vanish, go away. And it does a doggone good job of that. So we've got T30, T38, sending a fax in real time across the traditional network as well as IP networks. I find it, or we find it, helpful to look at T38 deployment in phases. Phase 1 was where FoIP was confined to the enterprise. Actually, these are phases of FoIP, but also a T38, where T38 came out in 1998, as I said, and it's used by enterprise organizations, others as well. And then somewhat past the midpoint of last decade, the SIP forum came out with the SIP trunking recommendation. And that's when we started to see a lot of problems because fax went beyond the confines of the enterprise network into service provider and carrier networks. Now in phase 3 we have international tandem carriers, and that just adds fuel to the fire. So in intra-enterprise you've got FoIP confined to the boundaries of the enterprise IP network. As soon as a fax from a terminal, say, hit the boundaries of the enterprise IP network, it got converted into PSTN and it went on its way. Now, if there were problems with this setup, the enterprise customer could crack the whip and get the vendor of the gateway or the server or the ATA or even the fax terminal to work with each other to iron out whatever problems they had, and everyone got happy a lot faster than sometimes they do today. So that's phase 1. Phase 2, where you're going to punch through the boundaries of the enterprise networks into a service provider, and that telephony service provider, who typically peers with IP carriers and onto the destination terminal. And this is when things got a lot more complicated. The difference between a lot of the architectures I'm going to be talking about is whether or not there is carrier routing involved. Carrier routing involved. Up until maybe 2007, 8, 9, or so on, you had the vendors of enterprise FoIP equipment, like ATAs, fax servers, and so on, that were learning a lot about FoIP, learning a lot about T38, and so on. But these guys out here, they were worried about making the IP networks, the global IP networks, work for voice, and they were still trying to learn how to spell fax. When the SIP trunking recommendation came out, and these guys said, wait a minute, I can make money, make more money by offering trunking to my enterprise customers, and they're thinking, yeah, they can call other companies and Aunt Martha and so on, save money. But lo and behold, they wanted to do it, use it to send faxes, and they said, whoa, that's causing trouble tickets that I really don't like. They're causing trouble tickets because they're routing a fax to IP carriers that may have never tested their networks for FoIP calls, and they don't necessarily route a call over what we call a fax-friendly route. In fact, some of them have fax-vicious routes. We did a lot of testing a few years ago, and we found that there were actually carriers that when they heard a fax tone, they would drop the call. I'm not kidding. That's kind of FoIP vicious. At any rate, phase 3, things got a little bit more complicated as you got international legacy carriers involved. Oftentimes, a route would go through a tandem TDM network and so on, and that added more delay, more problems, and gave you more opportunities for problems to occur. because these guys weren't necessarily setting their networks up correctly to handle FoIP calls. So it required some work to get there. And people say, well, why is fax so difficult? I've figured out voice. It didn't require much. The vendors could do it. Well, fax is difficult, relatively speaking, to voice. Voice is easy. You agree on a codec, you enable the media stream, you get rid of echo and so on, and you're done. Call setup timing is not critical. And that turned out to be the big problem with fax. With fax, timing is everything, and it's strict. Remember I said that the guys that developed T30 were aware of what timing requirements the PSTN or TDM network could support, and they took advantage of it. And if one end doesn't do something at a certain time or within a certain time period after the other end has done something, well, it doesn't work very often, or it has to retry. So timing is strict. It's a computer-computer protocol, as I explained, that has strict timing requirements. The modems in fax, which have to be transported somehow across an IP network, are synchronous modems, and the word synchronous has to do with time. The media stream typically begins as a voice call and wants to be renegotiated and switched to T38 if the carrier supports T38. And it has to be switched to T38 in time. So timing is everything with fax. Well, some of the companies we're going to be talking about thought that the problem was T38. Well, we found out it wasn't. Back in 2003, we found out it wasn't. Remember, we were working with the T38 interop test lab. One of our testing partners happened to be in Australia, and we didn't use carrier routing to connect from one testing party to another. We had so-called nailed-up IP connections. So we set up a T38 session with our testing partner and proceeded to transfer a 1,000-page fax. 1,000-page fax. And we went home. Came back the next morning. It had been successfully transferred overnight without a single image error. Now, we were, of course, taking advantage of the redundancy feature of T38, but at that time, and from then on, when someone says, well, T38 doesn't work, I say, it does work. I'll tell them the story. Is interop a problem? Can one piece of equipment from one vendor talk to another? Well, yeah, there's still interop problems, but they're not that many. FoIP and T38 are pretty mature. And as I said, we did a lot of testing in the early days and established a good foundation of interoperability in the industry. We'll pat ourselves on the back for that. And so today, and we work with a lot of service providers, we rarely find a T38 interop problem. It's even rarer to find a T30 problem. So if T30 isn't the problem and T38 is not the problem, where's the problem? Well, it can be in any one of places, several places. Problems can be caused, of course, by the CPE, by the Internet Telephony Service Provider, and by the carriers. But the number one T38 problem isn't T38. We did a lot of testing in the last part of the last decade with an OEM customer of ours, and they had a 2,000 number friendly fax list that we could fax to test. Happened to be their channel partners, their resellers. And we found that roughly 10% of all of the outbound calls failed. And try to make a long story short, they failed due to the T38 reinvite coming back from the network too late. When is it too late? Well, what's going on is the so-called off-ramp called or receiving gateway will typically initiate the re-invite. Well, that's after the fax has been routed to its destination. Destination terminal answers with the fax answer tone and a low-speed modem signal called the V21 signal to tell the caller what it can do as far as fax is concerned. So they can hear each other very early in the call, but sometimes it takes a long time for the call to traverse the route, so that when the gateway here or here says issues the T38 re-invite all the way back here, a lot has gone on. And this is the problem, actually, as they say, caught in the wild. A lot of you probably recognize a Wireshark trace. And right here at 4:34 seconds and a half seconds, where the called party says 200 OK to the invite up here, the two endpoint terminals can actually hear each other. Okay, so time marches on. March, 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 time. The call terminal says, hey, let's try T38. Let's look over here. This is 444.4 seconds or 3 seconds. This is 433. That's almost 10 seconds. Then the T38, the caller says okay, and the callee acts that 200 okay, and at that time, these two terminals decide to go from G711 to T38. Well, let's see what happened to the actual waveform. Before T38, you had the actual analog waveform reassembled via RTP, packet techniques, and so on. This is the calling tone from the calling terminal. The callee answers with fax tone. Then he uses what's called a digital information signal to tell, is that the right term, Cliff? DIS? To tell the caller,
Yes, that's the right term.
yeah, here's what we can do, here's what I can do. And so the caller says, okay, fine, there's a union of what I want to do and what you can do, so here's a signal to tell you what we're going to do. And we're going to train our modems. I'm going to train your modems to receive my signal. And that's right here. Look at the time. This is the 4:33 over here. Here's the 4:43 over here. That's where the T38 re-invite comes in. Bye-bye fax. That's like the two gateways pulling the rug out from under the two endpoints. You've heard the guy working on the street in New York saying, "Hey, I was working here." Well, that's what's going on with those two endpoint terminals. They were working here, and we just shut down the RTP, flipped over to T38, and those endpoint terminals don't know anything about T38, so they're gone. They've hung up, and someone has said, whoa, T38 doesn't work. Well, ladies and gentlemen, it ain't T38. It's the transition from G711 to T38 that didn't work. But when we found this out, it was the proverbial gobsmacking moment. We said, oh my gosh, we are guilty, and the entire industry is guilty of accepting T38 re-invites when they should reject the re-invite and stick with G711 for particular calls. A particular call, I should say. So what we decided to do was to not solve the problem with timers and things like that, because that doesn't work. Well, it doesn't work all the time. We attached the low-speed modem, the V21 modem that I mentioned a moment ago, to the RTP media stream. to track where those two endpoint terminals who are working here are in the T30 protocol. If the reinvite comes along after the point of no return, right here or here, depending on the designer, what we do is we tell the SIP logic in the gateway or the fax server, hey, if you receive a T38 reinvite after this message, you must decline it, because if you don't, you're going to kill the call. So do not accept it. So that was the solution. But of course, that means that instead of failing, we're going to stay with G711. And you all know, I'm sure that everyone on this call knows that that G711 could be problematic as well. We have found over the 2 decades that we've been dealing with, well, actually 1.5 decades, we've been dealing with IP, that the carriers in North America, Europe, have, well, just about every country or developing economy in the world are doing a great job of getting rid of dropped packets. Now, everyone here has probably seen packet loss, burst packet loss, out-of-order packets, and so on, but it's becoming less and less of a problem. But G711 failures in FoIP aren't becoming that much less of a problem. And that's because the problem is not missing packets, dropped packets. It is remember the business about it's about time? The biggest problem with G711 today is that the clocks in the endpoint and the clocks in the gateway are not synchronized. So in the gateway you have a jitter buffer clock where the jitter buffer is accumulating the data being transmitted by the modem, and it is playing it out synchronously to the IP network over here, using a jitter buffer to control it. The jitter buffer accumulates packets and then plays them out synchronously. And these two clocks are different. They're always different. The question is, how much are they different? Are they different in opposite directions? Well, if they are different in opposite directions, the errors are cumulative. And if the fax is long enough, the jitter buffer will eventually, the jitter buffer in the gateway here will eventually underrun, empty, or overrun, start tossing packets. Either way, you have a failed fax. So it's not a question of if, it's a question of when or how long the fax can be. And the T30 recommendation puts no limit on fax length. And most gateways do not reset their jitter buffer once the fax session begins. So the more pages that are sent, the more likely it is to fail early. So those of you who are service providers have probably heard this. I can send a one-page fax with 99.9% completion rate. And a lot of times I can send a 2-page. But 3, 4, 5-page faxes, forget it. I can't do it. Well, it's not because of there being more chance of a dropped packet, although I guess there is. There is more time for these clocks to build up the cumulative error and for the jitter buffer to underrun or overrun. Don't ask me to recreate it, but one time I spent a head scratching 30 minutes figuring out that if the two endpoints had 50 part per million oscillators, if they were off in different directions, one fast, one slow, you've got 100 parts per million. That kind of difference will completely eat up a 250 millisecond jitter buffer in 40 seconds. And that's a 1.5-page fax at 14.4K bits per second. And that's why your subscribers are saying, I can't send a 2-page or a 3-page or 4-page fax. So what do we do about that? Well, we said that we've got this V21 modem watching what's going on, and Fax is a half-duplex protocol, and there are times between pages when neither modem is talking. If you can reinitialize your jitter buffer at that moment, as far as the jitter buffers are concerned, you can make an in-page fax look like in one-page faxes. Not to the endpoint. You know, they just see, if it's a 10-page fax, they just see a 10-page fax. But that jitter buffer sees 10 one-page faxes, and it works. And the success rates in the field have been, well, everything we figured they would be. So Smart FoIP takes care of these two major problems and gives you reduced development costs if you're an OEM, support costs if you're a service provider. It's all industry standard. It does not require Smart FoIP on both ends. It works just on one end. And it lets you service providers stop saying to your customers, keep your pots for fax. You put that revenue in your pocket. Now, we are currently adding Smart FoIP to Bladeware. We have release 3.0 coming out, I'd say in about 2 weeks. Bladeware is our HMP media server. It's in NetGen's Smart ATA, has been for a couple of years now. And we solved 3 big problems. Just to review, slow late T38 reinvites, G7 pass-through PCM clock problems, and Smart FoIP integrates the control logic and state machines for integrating V34 fax into SIP networks, or actually SIP gateways. Okay, so I said we were going to be talking about different approaches to making reliable image transfer across IP networks work. And FaxBack was one of the first companies to figure out how to do that. And they did it by avoiding T38, although I have it here, I think that may be wrong. So what they did was they said, okay, what we're going to do here is we're going to come up with an ATA that actually receives the fax. So if this guy is transmitting, the ATA receives the image incrementally, packages it up, and uses HTTPS, which is, of course, I guess you could say internet protocol or web protocol, to transfer the image from the ATA on the customer premises to a hosted server. The hosted server then sends the fax out over the PSTN, either by, and I'm not sure how, maybe some of you are more familiar with FaxBack than I am, but they either use a connection to a gateway or just directly use fax boards to send out to the PSTN. But the essential ingredient here is that there is no carrier routing involved of FoIP. They avoided it altogether, and so the fax gets successfully transferred from here to a fax terminal over here as reliably or nearly so as regular PSTN fax. And they've done a good job of it. What's the difference between that and Smart FoIP? Well, it's not industry standard. You have to bear the cost, and someone's got to pay for it, of this additional infrastructure. This is a non-standard ATA that terminates incrementally T30 sessions rather than relays them. FaxBox is another company, it was recently purchased by Sangoma, that does a fine job of getting image files from point A to point B using IP networks, but again, avoiding carrier routing of the FoIP. Instead of a proprietary ATA, they actually use a server appliance on premises, and I believe their business model is to charge monthly subscription fees for this. But they did basically the same thing as FaxBack does, and that is to transport the fax. And here it's I think it's done a page at a time, to their hosted servers and from there out to the PSTN. Because this is hosted, they can, and you can see this on their website, do a good job of getting faxes through geosynchronous satellites and so on. But I guess I'm not using my term correctly. It's not really an end-to-end real-time fax. What they're doing is they're emailing image files around. But as far as the user is concerned, it looks like a fax. Okay, got a fax terminal here, got a fax terminal here. You put it in here. A while later, it comes out here. And so most people think it's a fax. But I'm assuming that most of you are service providers or have a deep technical interest in this. You might want to know the differences between the different architectures. Now, our service provider is Cebion. I guess they were recently purchased by Birch Communications, and this is the way they do it. Now, we have on our premises, well, it's really called an integrated access device. It's a Cisco 2400. And we've got a fax terminal connected to it using a derived TDM line. So we've got T30 between this endpoint and an endpoint over here. It's analog here. I'm about to make the same mistake I fault other people in. The Cisco sends our fax call to the Cebion Metropolitan Area IP network, which is very high performance, very well managed, with no third-party carrier routing. It's a common theme. You stay away from third-party FoIP routing, you can make an FoIP call work. Remember, our 1,000-page fax, there was no routing at all involved there. We had, we exchanged via email the IP address of each endpoint. And our service provider then takes the call and uses their gateway to connect with, well, here in Georgia, it's going to be AT&T's PSTN network. And that works. We never see an FoIP problem, although we have a fax terminal connected to an FoIP network. There's no carrier routing involved. Another way is total avoidance. Etherfax has an innovative business model, or actually architectural model, I should say, where they partner with the vendors of fax servers. If you go to their website, just about every fax server vendor, or at least the top tier of them, have partnered with Etherfax to create connectors between the on-premises server and the Etherfax fax servers. Now that is not a real-time protocol at all. This guy just says, look, I want to send this fax to this telephone number. Here's the list of recipients, and so on. And this guy says, okay, I'll do that for you, and I'll let you know. And of course, if any of you have used a fax server, and I believe probably most of you have, you know what the client interface to a fax server looks like. It shows you that your fax went, so on and so forth, assuming it did go. And here, Etherfax is playing the architectural role of a fax board, or an IP or SIP connection. This is not a SIP connection. It is a proprietary server to Etherfax connection. Their server farms send the faxes directly. But as far as this company is concerned, hey, I didn't have to worry about fax boards. It works. I'm happy. So they've got a solution that works as well. But if you're going to use carriers to route FoIP calls, you need to get rid of those problems. And to do that, you need to partner with a vendor that knows how to do it. And we suggest that we are just that vendor. But we can help you take care of that late T30 reinvite problem. We can help you take care of the G711 problem with our proprietary technology. But then where we shine beyond that is our over-the-top, through flaming hoops support for our ITSP customers to make FoIP work, to iron out those carrier problems and get where you want to be. Now, that does not require that hosted infrastructure that the other diagrams did, the other companies do. And so we have learned that not all FoIP routes are created equal. What you want really is the same thing that someone that's vending high definition or HD voice requires. You might be aware that for HD to work, you need a wideband codec and a wideband connection. The 4 KB bandwidth and the 8 KB sample rate of a POTS line just won't do for HD voice. So you have to route it over IP, and you want to do the same thing for FoIP. You don't have to, but you want to. Even if you can get an IP connection, oftentimes there are segments that aren't tested. All carriers have SBCs, proxy servers, gateways, and so on, but some of them don't have them correctly configured for FoIP. And then, of course, the more entities or networks involved in the route, the more chance you have not only for a configuration problem or some other kind of problem, but the more delay you have. And you can even find that routes will change throughout the day based on the least cost routing algorithm of the carrier. Okay, one other thing, and I'm going to turn the floor over to Cliff so you can take your questions. We did a lot of testing several years ago, and as I mentioned previously, the called gateway is responsible for the T38 reinvite, at least for V17 calls. That's the modem that handles a 14.4K bit rate. Well, you might be thinking, well, he also told me that the reinvite is at the endpoint, but by the time we get to the endpoint and the endpoint terminal answers with fax tones, the route is all predetermined. It's too late. Okay, well, we could do something about that. As a service provider, you can assign a particular telephone number as a fax number and say, okay, I'm going to proactively route any call from that number over my proven fax routes. Now, a lot of people do that, by the way. It's a little more expensive, but hey, that subscriber is paying over $40 a month for his POTS line. He'll gladly spend a little more per fax trunk than he does for voice, provided it doesn't cause a pain. Well, it turns out there's RFCs that allow the SIP header to specify preferred routing or preferred endpoint. They're listed here. And so the folks at the SIP forum said, okay, well, why don't we use this capability to tell the routing entities, the routing algorithms, that this wants to be a fax call. So select a fax qualified route. Especially don't select one of those nasty old fax vicious routes. And so we said, okay, we read these, they read these standards and found that you could specify media preference in the contact header. They're listed here. Well, go down through that, ladies and gentlemen. Do you see fax? Nope, no fax listed. They said, for God's sakes, you know, fax, in the, who's the comedian that says don't get no respect? Fax don't get no respect. And so we said, well, let's add some respect and let's come up with a recommendation, an IETF recommendation that adds fax to that list. And the SIP forum did. They submitted it in 2012, but 2 or 3 years ago anyway. It was determined or accepted, put into an RFC by the IETF, adding SIP.fax equals T38 and SIP.fax equals pass-through You can put it in the contact header of your SIP invite, and the routing entity can parse it out, determine that, hey, this is a fax call. Well, it's a little bit of a chicken or egg thing, but we have to start somewhere, folks. And NetGen Communications Smart ATA now supports RFC 6913, as does Commetrex Bladeware. So one of the things you can do is you can ask your equipment vendor, do you support RFC 6913? You know, I'm not saying that that is necessary and sufficient reason to select our equipment, although I wish it were. But if they get asked enough, they just might add it. And if they add it, and we want everyone to add it, the world will be a better place, believe me. If all of this fails, we still have a product called FaxTap NG that picks up where Wireshark leaves off. It allows you to troubleshoot just about any fax call. It also has an OEM version that is used in lawful intercept applications. And it's loaded with features. It's got a nice GUI interface, works on Linux and Windows. It even is able to, well, you won't appreciate this, but some of you will. It allows you to render the image of an NFS NSS call. It gives you an analysis of the line quality for the analog modems, gives you analysis of packet loss. It is quite a product, and it was done by Mr. Shornack, to whom I'm going to turn over the meeting. And if you stump him, it's not a fax question. Let me, John, what do I do here? Let's see. How do I turn this?
He actually doesn't need control. If everybody wants to raise their hand if they have a question, I will go ahead and make it so you're audible and you can ask Cliff the question.
Cliff, you there?
Yes, I'm here.
Okay, somebody try to stump Cliff with a question.
I'll go ahead and start. Cliff, what do you think the greatest benefit the Smart ATA offers to the marketplace and to vendors to provide for their customers?
Basically, it provides a fax solution to handle the multiple network hop problem. It takes care of the late T38 reinvite, which generally is caused by multiple hop network connections. And it takes care of the PCM clock sync problems. And basically just makes the ATA work pretty well. I mean, G711 pass-through faxes, as long as you get rid of this clock sync, work pretty well. Lost packets aren't, as Mike said, aren't a big deal anymore. So that's the biggest thing. I mean, it is a very nice full-function ATA. On top of that, I mean, doing all the normal things that an ATA does,
including voice.
Yeah, including voice. It's a regular
and
ATA.
V34.
That's another thing. It does have V34, which is kind of rare in an ATA.
It also, if I could just jump in, which you expected probably, Cliff. There's a version of Smart ATA, and we even have an 8-port version right now that offers 2 to 8 office trunks. So it supports V34. That means you can put one of our devices in front of a SIP fax server in lieu of fax boards. Now these devices are, you know, $30 to $50 a port. Compare that to the price of a fax boards, and you'll see that it's a pretty good deal, and you don't have to give up V34. What's more, once the customer, the user, decides to move from PSTN to IP, you can either toss the ATA or repurpose it from some other application.
Mike, I have a question from Michael Preverzhensky. I hope I pronounced that correctly. What is your HMP product license list price per port? And does it support V.34, T.30 pass-through, and T.38?
Supports all of those. The bare bones price per port's a little over $100. I think $136.50. If you add, and we have a couple of carrier applications that some of our carrier customers twisted our arm and made us develop fax to email, email to fax. If you add those, it adds to it. But for budgetary purposes, look at a little over $100 per port as a one-time license fee.
And what are we looking at for the Smart ATA?
Well, it's the list price of the 2-port version is $98.50. 4-port is $120, and the 8-port $270.
And how much is the average cost of a TDM line, POTS line?
Yeah.
I'm just, last time I checked, it was $45.
That's typical.
Do we have any more questions from anybody else out there? I see we still have people online, but I think you have addressed their questions quite favorably.
Thanks, everybody.
So at this time, if you would like, I will be sending out a copy of these slides to everyone probably tomorrow. And if you have any additional questions or would like to learn about our channel partner program, please feel free to send me an email. I'm jsummit@netgencommunications.com, or feel free to reach out to Mike and Cliff.
Thanks, John.
Thank you, everybody, and you have a wonderful day.